All right, class, today we're going to be studying section 10.2, which is the law of sines. We are going to be able to use the law of sines to solve triangles. The law of sines is quite different from the law of cosines. The law of sines comes from proportions. The law of sines basically states that the sine of an angle over its opposite side has to be proportional to the sine of another angle and its opposite side. This equation has three parts to it, but technically you only need two to create the proportion. This equation could also be flipped. You could say A over the sine of A equals B over the sine of angle B equals C over the sine of angle C. But either way, the key thing to remember about the law of sines is that it's proportional. It's a big, giant proportion. There are three cases that you can use and apply the law of sines. The first case is when you have two angles and a non-included side. So if I gave this triangle some measurements or some labels, I would say the sine of A over side A would equal the sine of B over side B. I wouldn't be using anything with angle C because I don't have any measurements of sides or angles that deal with angle C. The second case is when you have two angles and an included side. Two angles and one included side, meaning the side is in between the two angles. If I give this triangle some labels, in this case I could set up several different things given what I know. I can find the third angle by subtracting these two from 180. And I could apply the situation and say the sine of A over side A would equal the sine of B over side B. And in this case, I would be finding the measure of side A. And I could apply things with side and angle C as well. The third case is the hardest case to deal with because we have two sides and a non-included angle. This is called the ambiguous case because in this case, we can have 1, 2, or no triangles. This largely occurs because we have to find an angle. And since the sine is positive in the first and the second quadrants, we have two potential angles that could work. Let's do an example. I want to solve this triangle, which means I need to find all of the missing parts. The first thing I'm going to do is find the easiest measurement, and that would be the measure of angle A, which would be found by subtracting 71 and 28 from 180. So 180 minus 71 minus 28 would be 81 degrees. Now we have to apply the law of sines. Now I will apply the law of sines. I could pick any side I want, but I have to find side B and I have to find side C. I'll start with side B. So I'll take the sine of 28 over side B. We'll have to equal the sine of 81 over 15. Then I'll cross multiply. 15 times the sine of 28 equals b times the sine of 81. Then I'll get b by itself by dividing both sides by the sine of 81. Punch it in my calculator, and I get b equals 7.13. Now I can apply the same process to find side C. To find side C, I'll take the sine of 71 over side C equals the sine of 81 over 15. I could have used the side I just found as well. Either way, I'll get the same answer. But the process repeats itself. I'll multiply both sides by 15 and by C. Then I'll divide by the sine of 81. I'll put it in my calculator, and C will end up equaling about 14.36. We'll work with the law of sines more in class, and we'll talk about the ambiguous case. Please write down any questions that you may have.